Hello students, welcome to your last video lesson, lesson 8.12 and 8.13. We're going to be applying today what we talked about in our last video, the race to infinity, dominant terms, which functions get to infinity the fastest, and so on, okay? We're going to continue talking about dominant terms, the winners of the race to infinity, in the context of rational functions. And a rational function, for those of you that don't remember, is just a function that looks like a fraction. Okay, and on the top and bottom, there's some polynomial or some collection of terms, some collection of functions that make a fraction. Okay, so these rational functions, everything that we're going to do today is going to look like a fraction. Okay, functions that look like fractions. In this first example, we have a polynomial on the top and on the bottom of the fraction. 3x to the fifth plus 2x to the fourth minus x squared is the top, the numerator of the fraction. 2x squared plus x minus 100 is the denominator. The only question we need to ask ourselves in order to find the limit as x approaches infinity, or as x approaches negative infinity, we will talk about both, the limit as x approaches infinity of this function. In order to answer that question, I need to just figure out where is the dominant term in this function. So I look at all the terms, top and bottom together, and I decide which of these terms is going to win the race to infinity. Now, it is important to remember from our last video that anything multiplied on does not matter in terms of dominance. Anything added or subtracted on does not matter in terms of dominance. So I don't care that there's a minus 100 on the bottom, and I don't care that this is being multiplied by 2 and multiplied by 2 and multiplied by 3. I don't care about any of that. I'm just looking at the actual function. What is happening to the variable? Where is the variable? What type of function is it? And in this particular case, the dominant term is right here. 3x to the fifth is the dominant term. It would win the race to infinity because there are no exponential functions. Remember, those were the ultimate winners, something to the x power, exponential growth functions. But in this case, there are none of those, and x to the fifth is the highest exponent, the highest power, so that wins the race to infinity. So because the dominant term, in this case, is on the top of the fraction, the entire bottom of the fraction is completely meaningless. Because in terms of, or in light of 3x to the fifth, when x gets very, very large, the bottom of the fraction is negligible. Okay, it's basically like 1. Imagine if it said 3x to the fifth plus 2x to the fourth minus x squared over 1, or over 3, or over 5. It doesn't really matter. If x gets gigantic, the bottom of this fraction means absolutely nothing. Okay. Similarly, on the top of the fraction, because I've identified the dominant term, the other two pieces also mean nothing. So the limit as x approaches infinity for this function is just whatever happens as x goes to infinity for this dominant term. And a positive infinity raised up to the fifth power is going to be an even bigger positive number, and then I'm going to multiply it by 3, and it's an even bigger positive number. So this limit is infinity. Okay? Now, in this case, if I were to do the limit as x approaches negative infinity, the same exact thing is true, or most of what I just said is true. The bottom doesn't matter because the dominant term is on the top. The rest of the top doesn't matter. And all I'm looking at is 3x to the fifth. All I'm looking at is this dominant term. Whoops, this is supposed to be as x approaches negative infinity. If I put a negative number in for x, and I raise it to the fifth power, a negative number to the fifth power is still negative, multiplied by 3 is still negative. So in this particular case, 3x to the fifth, when x goes to negative infinity, my limit is also negative infinity. Okay? Now, a general rule here, if the dominant term is on the top of the function, then the limit as x approaches infinity or negative infinity is infinity or negative infinity, depending on what's happening with the dominant term. Okay? It's all solely based on the dominant term. If your dominant term is in your numerator on the top of the fraction, then the entire function as x approaches infinity or negative infinity is going to also approach infinity or negative infinity. Okay? We basically forget about the bottom of the function and everything besides that dominant term. Okay? Now, if the x approaches, or excuse me, if the dominant term, which is what I'm worried about, is on the bottom of the function, then the limit as x approaches infinity or negative infinity is always 0, okay, no matter what, because we imagine that the top of the function is really 1, okay, and here's an example of that. Okay, so now here's a function, and if I'm looking again for the dominant term, where is the dominant term? Look at all the pieces, numerator and denominator, find the one that wins the raised to infinity. Well, I mean, this one, 3x to the fourth, looks like it's going to beat 4x squared, right? And it's going to beat out 3x. But look at what we have here at the end. Whoops, that is supposed to be a pen. Whoopsies. Look at what we have here, okay? This guy right here is the dominant term. 2 to the power of x, an exponential growth function, is going to win the raised to infinity. So because that dominant term is on the bottom, all of this stuff on the top of the fraction is basically nothing in light of that. Because 2 to the x is going to get so huge, so fast, that it's going to be way, way bigger than 3x to the fourth minus 230,000. Okay, none of this stuff up here matters at all. So what we decided, we pretend that the entire top of the fraction is essentially 1, right? Because it doesn't matter if it's 1 over this crazy stuff, or 2 over this big stuff, or 5 over this big stuff. In light of 2 to the x, this top of the fraction is small. It's 1, it's 10, it's 15. It doesn't matter. It's some number that is small, minuscule, tiny compared to 2 to the x. This is the dominant term. So if we have 1 over, 2 to the x can get really, really big. Let's say it's 1 over 300. That's extremely small, right? Even if we made it, let's say 15 over 30,000, that's even smaller, right? So when the dominant term is on the bottom of the function, whether you're going to positive infinity or negative infinity, remember dominant terms are a little different going to negative infinity, but when your dominant term is on the bottom of the function, the limit as x approaches infinity or negative infinity is 0. So this limit as x approaches infinity, in this case of g of x, is 0. The same is true for the limit as x approaches, actually in this case, as x approaches negative infinity, I had to catch myself there. This is not the same, okay? Because as x approaches negative infinity, remember what we said in the last video. What does not count when x is going to negative infinity? It's exactly these exponential growth functions, okay? So that's not there anymore. So I reevaluate then, where's my dominant term now? And my dominant term is actually here, right? Once the 2 to the x is gone because I'm going to negative infinity, so exponential growth is completely meaningless, my new dominant term is on the top. So if the new dominant term is on the top, I need to decide, is that dominant term going to positive infinity or negative infinity, right? And in this case, I have a negative infinity that's being plugged in for x, being raised to the 4th power. A negative number to the 4th power is going to be some bigger positive number. Then I multiply it by 3 and it's still positive. So in this case, my limit is actually infinity, okay? My limit's infinity. So as you're going to negative infinity, remember that the exponentials don't count anymore. But again, if the dominant term, whether you're going to positive infinity or negative infinity, if the dominant term is on the bottom, the limit is going to 0, okay? And then finally, the only other option, if the dominant term is not on the top, not on the bottom, is what if they are equally dominant, okay? What if the top and bottom of the function have an equally dominant term like we have here, right? If I look at these terms, 3x to the third minus 540,220 over 4x to the third minus 3x squared plus 2x, the dominant term, or the winner of the raised to infinity, remember, we're ignoring what it's multiplied by or what it's added to, right? My dominant terms are here and here. These are equally dominant because they're both x to the third power. And x to the third power is the same top and bottom here, right? There's nothing that's going to beat out x to the third power in any of these terms. So 3x to the third over 4x to the third, those are my dominant terms. I can still ignore everything besides those dominant terms. So the 540,220 doesn't matter. The 3x squared plus 2x doesn't matter, because in comparison to 3x to the third and 4x to the third, all of that stuff is extremely small. okay, as x gets close to infinity, as x gets huge. So if we just pretend that this was my function, if my function now becomes 3x to the third over 4x to the third, these are equally dominant, right? Well, can't this function here simplify down? We basically can cancel out the x to the thirds, and my whole function just says this. Okay, and that's actually what the limit is equal to as well. Okay, the limit as x approaches, whoops, this is supposed to be k of x, as x approaches infinity or negative infinity is equal to, in this case, 3/4. Okay, it is equal to the ratio or fraction made of the coefficients of those equally dominant terms. So if you have equally dominant terms top and bottom, you ignore the rest, you cancel out the function part, and you just make a fraction out of the coefficients. Okay, so in this case, the limit is 3/4. And if I went to negative infinity, it would be the same, because x to the third, if I put a giant negative number in there, there's going to be some negative big number. The same is true on the bottom, right? It doesn't matter if x is getting really big positive or really big negative. X to the third over x to the third is going to cancel out anyway. So it's still 3/4, no matter what, okay? So those are your three options in terms of limits as x approaches infinity or negative infinity for rational functions. Where is the dominant term? And what does that tell you about the function as x gets really, really large positive or really, really large negative, okay? So with that information in mind, you should be able to do most of the work that I'm asking you to do, most of the problems for this video. The one that I'm gonna help you out with is actually the very last one, number 42. When you get there, I want you to ignore the directions. Okay, I want you to ignore the directions. It's not really what I'm worried about. What I want to see you do for number 42, or what we're going to do together, is we're going to find the limit as x approaches infinity for this function g of x. Okay, together. Now, if x is approaching infinity, and I want to find the limit in this case, I should really find the dominant term of this function, right? So I want you to notice that the dominant term is right down here, right? X squared. However, that dominant term is underneath of a square root symbol. And now the fact that this dominant term is underneath of a square root symbol is actually going to affect our limit here, okay? Now, normally, we would ignore everything besides this dominant term, right? I'm still going to do that on the bottom because I hope that you all agree that minusing 5 from 10 million squared isn't really doing anything, right? So the -5 really doesn't mean anything. But when I get rid of that -5, notice what the bottom of the fraction now says. It's now just the square root of x squared, okay? And this is true because x is getting extremely large, and that -5 is essentially nothing, okay? So this is like x squared minus something so small that it doesn't matter at all. But what is the square root of x squared? Square root of x squared. If the -5 doesn't matter and it isn't even there anymore, or we just imagine and pretend that it's not because it's so negligible, what happens when I then square root x squared? Well, that's basically just x, right? Isn't the square root of x squared equal to x? So in this case, the bottom of the fraction is now x. The top still, I guess, says 3x minus the square root of x. And now notice that this has changed some things about my dominant term, right? Because now I have a 3x minus radical x over x. And my terms are equally dominant now on the top with my 3x and on the bottom with, I guess, what I'll pretend is a 1x, right? So because that -5, we get to pretend it's not there, the bottom of the fraction is not really x squared anymore, it's just x, okay? So now my terms are equally dominant, top and bottom of the fraction, equally dominant. So what is the limit as x approaches infinity in this case? The limit is 3/1, right? Because the x's cancel out. It's a ratio of the coefficients, which of course is just equal to 3. So if you were to put in any gigantic number into this function for all of these different x's, the limit or excuse me, the value of the function would get closer and closer and closer and closer to 3 as your x increased. Okay, and that's really what they were asking you to do in the directions about making a table, showing a graph, and so on. And you're welcome to do that. I do think that it can be helpful. But we can also think about these types of things algebraically. Okay, when we have dominant terms that are inside of other functions, like the square root of x squared, and so on. Or, you know, if you had something like, you know, 3x to the fourth, you know, we'd have to think of that really as, you know, 3 to the fourth and x to the fourth, so it would really be, what, 81 times x to the fourth. So things can change if we think algebraically about x approaching infinity, right? So the limit for 42 is 3. If you have any questions about how dominant terms affect the limits of these rational functions, do please let me know. Otherwise, I think you are prepared now to complete all of the problems I have assigned for this video. If you have questions or concerns, reach out to me. I'm always available. Otherwise, that's all I have for you right now, and we'll talk to you soon.